Hi and welcome to today's class. It is the 1st of May and this is class number 57. So today we're going to look at something called expected frequency, and we're going to look at relative frequency and experimental probability. All of these are really big words, but what they do with regards to probability is quite straightforward. So when we talk about relative frequency, I prefer to call it experimental probability. Because when we call it experimental probability, it makes sense. Because it's the probability that we get from an experiment. So sometimes it can be too difficult to work out the probability of an event. We may need to take motion and or pressure into account, along with the never-ending list of other things which may affect the outcome. For instance, there is enormous pressure on a penalty taker in football matches. Maybe he'll slip in the rain. In this case, we often rely on statistical evidence to find what's called the relative frequency or the experimental probability. So if I asked you to take a shot on a goal or on a basketball hoop, there is either you'll score or you'll miss. So you might say, well, is that like 50-50 chance? Well, I don't think it's 50-50. Maybe it is in some cases. But what they do is instead they look at the performance that has happened previously to make a judgment. So if you ever watch any sport, so I'll take soccer for example, if somebody's taking a penalty, they might discuss how many penalties that person has taken over the season and then how many of those penalties they've scored. That will give us a good indication of a probability of making the next one. So using what's happened in the past to decide or to help predict what will happen in the future. So for example, if you're on a basketball team and your team has won 8 out of the last 10 matches, you'd say that you must be pretty good, so then the chances of you winning the next game are pretty good. But if you were a basketball team and you won 3 out of the last 10 games, you're probably saying, oh, you're not great. So the chance or the probability of you winning your next game is much lower. In fact, that probability will be 3 out of 10. So how we calculate this experimental probability is the times it's happened over the times it's tried. So how many goals did you score and how many did you try and score? So maybe you scored 4 out of your 10 penalties. That will give us a probability of 4 out of 10 or 2 out of 5. So it's just a different way of getting a probability, and it's much more real world, and it's much more likely that we'll see this in sports and lots of other places. So let's take an example. The penalty taker for a soccer team took 25 penalties during the season. He scored 20 of them. What is the relative frequency? Now remember, relative frequency is another way to say experimental probability. What is the relative frequency of scoring a penalty? So based off experience, he scored 20 out of 25. Now, you all have done fractions with me this year and know that this is not in its simplest form. Divide above and below by 5 and that gives us a 4 in 5 chance of scoring. So the probability of him scoring based off his history is going to be 4 in 5. So then we're going to look at something that's called expected frequency. Okay, so this example is expected frequency. What do we expect based off probability? Frequency. When the same player takes 10 penalties in next season, how many do you expect him to score? So remember, I've continuously made the connection between probability and the fraction of things. So for example, there's a 4 in 5 chance he will make the next penalty, but that's also another way of saying he scores 4/5 of his penalty. So to get the expected frequency, we multiply our probability by the number of times that we've done something. So 4/5 by 10. Now, you can do this yourself. So that's 4 over 5 by 10 over 1. Multiply across the top and across the bottom, and that gives us 8. Or you could have gone straight to your calculator to do it. So we would expect that the player would make or would score 8 out of those 10 penalties. So we're going to do a flip a coin experiment. So pause the video and please go in search of a coin. If you're using a euro, Sometimes it's get confusing, heads and tails. In Ireland, we use the terminology head and harp sometimes instead of tails. So heads is the one with the number on it. Tails is the one with the picture. Okay, heads and tails. So I want you to find a coin and to toss it 30 times and record your results. So take down this table. So you would take it down like a tally. So you did tallies with Miss Finn. So you might get heads, heads again, then you get a tails, then you get another heads, then you get a tails, then you get another tails, then another heads, and then your fifth head you can cross it like this. And you should have these little baskets of 5. So 4 and a line through it. When you get that, you then have the total number. So I should have 30. So let's say I had 16 heads and 14 tails. The fraction of the total, that would be 16 out of 30, and this would be 14 out of 30, and then you would simplify those if you could. That would be 7 out of 15 and 8 out of 15, and then you can change it to a percentage. Remember, to get a percentage, you would write your fraction and you multiply by 100 or 100 over 1. Okay, that's how you get your percentage. Is this what you predicted? And add together the two relative frequencies. So add this number and this number together, and what do you get? So I did say, I just forgot to read it. Before you start, how many times do you think you'll get heads and how many times do you think you will get tails? So make that little prediction. So pause the video, do your little experiment, take it down in your copy, and when you have that done, you come back to the video. Okay, so hopefully you have that experiment done. If you predicted 15 heads and 15 tails, that's a very, very good prediction. However, although that's perfect mathematically, it's not what generally happens in the real world. Now, unfortunately, we're not in a class, so we can't really survey you guys. However, I'm sure if I asked how many of you got 15 and 15, some of you will have. And some of you might have got 14 and 16 like I had got. Maybe there's somebody got 12 and 18. Sometimes people get 10 and 20. But basically, this is not going to be perfect. It's not going to be fully accurate. How we get more accurate answers is doing it more and more times. So we only toss it 30 times. You toss it 100, it'll be more accurate. Toss it 200, it'll be even more accurate. Toss it 1,000 times and you'll start to see it line up half and half. Your relative frequency should have hopefully been close to a half. If it was exactly a half, great. If it was close to a half, brilliant. How you'll know if it's close to half was the percentage. So it should be 50-50. If it's anywhere in the 40s and 50s, you're perfect. If you got below, if you got like a 30 and the 70 or 30 and the 60, then something, oh, was funny, try it again. Maybe you'll get something different. Maybe there's something wrong with your coin. But you might have got what you predicted or close to it, or maybe you didn't. When you add together the relative frequencies, you should find that they add together to give you 1. And that is true because the probability of getting heads and the probability of getting a tails, it's certain that you're going to get one of them. So when you add them together, you'll get 1. So now I have a little exercise for you. This is called Diffuse the Bomb. So I have 8 questions, and based off those 8 questions, it tells you what color wires you should cut first. So if you cut them in the wrong order, kaboom! So you don't want to make the bomb go kaboom. So it's nice because I've given you the answers up there so you can get your colors. So what I'd like you to do is to work through these. Some of them are very challenging, but what I'd say, if you have a challenging one, skip it. And when you've skipped it, then you might find one of your answers up above that is left over. You know, be smart about it. And see, do they make sense? And send me through your list of colours, okay? I'd like to see your workings as well, but really clearly, sometimes it's very hard to see on your pictures. Just give me the list of colours and I will tell you if you've correctly diffused the bomb. Good luck.